This is industrial networking. And we're discussing Project 5 for DH45 networks. Okay, so we look at Project 5, and it says I'm hooking up a variable speed controller, and the key to this is program the PowerFlex, blah, 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 blah. We are to use the sync output card. Three-phase motor. So we have to use the sync position of the PowerFlex. Okay, so that's using sync wiring on the PowerFlex right there. That's what I wanted to see. So right there is what we're doing. Okay, so there's a sync source selector switch on the PowerFlex. We're putting it in the sync position. Now, Project 4 and Project 5 are virtually the same. I'm going to look at my PowerFlex program that I wrote for Project 5, and I see that my output is going to a AC card, and I go look at my configuration, and I see I have a output sync card sitting at in slot 4. So all I'm going to do is change my outputs to output 4. I'll stop. I'm going to change my output to output 4. Start forward. Change my output to output 4. Reverse. Change my output to output 4. Reverse. Change my output to output 4. And now my program's written. I'm ready to go. And all I have to do is do the wiring to the PowerFlex. Okay, so we come back and we look at our wiring scheme that we did in Project 4. And we notice that because we're using the output sync card, we don't have a AC to DC mismatch problem, so I don't need my any of the relays that I wired, so I can just get rid of all of them and say, isn't that nice? And then I can say, well, what am I going to do then? If I'm not hooking up to those relays, what am I going to do? And I'm going to say, well, what I'm going to do is I'm going to take my DC sync card, DC sync, and there's a DC common on the bottom, and I'm going to hook up DC common to pin 4. And then my start, I'm going to hook it up here to output 0, and so that's start. And I'm going to take start forward. That's wrong. 0 is being used for speed, so we'll cancel that idea. Boom, come down, do it again. Okay, so the least significant digit of speed is being hooked up to output 0. The middle digit of speed is being hooked up to 1, and the most significant bit of speed is being hooked up to 2. And the stop is connected to 3, and the start forward is connected to 4. And the reverse is hooked up to 5. So now I've wired the PowerFlex to the sync card, and we have this sync source switch on the PowerFlex. Is the sync on the top or the bottom? Sync is on top. SNK and source S. Source. How do we spell source? SRC. SRC is on the bottom, and we're going to put the switch up on top. So now we're in sync wiring, we're in 3-wire control, we're in digital control, the PowerFlex is ready to go. All the outputs, all the binary bits were the same, so the panel view should work, and that's all we have to do to make this guy work in a DC sync situation. Now, we have one problem out of 6. Okay, so there's one chance out of 6 that we have the following problem, that our sync card channel 1 is broken. So way back when, 5-10 years ago or whatever, AC power was sent into channel 1 of a DC sync card, burning that channel up. It doesn't work. Alright, so what am I going to do? I'm gonna have to do something. So what is it that I'm gonna have to do? Well, I can't put my speed at 0, 1, and 2 anymore. I'm gonna have to put it someplace else. All right, so where do you want to put it? And so that's the issue. So 0, 1, 2, 3, 4, 5 are being used. So we're going to use 6, 7, and 8. Those are the guys we're going to be using for our speed. So this is going to be speed 3. That's going to be speed 1. This is going to be speed 2. Now, how are we going to do that? This is the 0. This is a unit 2, 4, 8, 16, 32, the 64 spot. Okay, so what we're going to do is we're going to rewrite our program, and instead of using a counter, so we'll get rid of the counter, and we'll use an add instruction. Now, because we already have a one-shot rising there, that is convenient. Where did my math program go anyway? There it is, math. And because the add instructor is going to add on every scan, the one-shot rising is going to prevent it from adding on every scan. So we're not using integer n7 colon 0 yet, because we're not using any integer. And we'll call that integer speed. And we're going to add a 64 to it. And we're going to send it to n7 colon 0. All right. And then we're going to ask ourselves, what mask are we going to use? Okay, so we're going to mask move n7 colon 0 someplace to the outputs. Okay, that's good. But what mask should we use? Okay, so we want a mask that's 1, 1, 1, 0, 0, 0, 0, 0, 0. So what is that in hexadecimal? We make these guys in 3s. That's a 1 Charlie 0 in hexadecimal is going to be our mask. 1 Charlie 0 hex. All right, now when we get to 111 and then we go to the 0, 0, 0, what happens at that point? We're adding, and we go from there and we go to 1, 0, 0, 0. 0, 0, 0, 0, 0, 0. And so we look at that, and we look at that, and we well, this is the 64, 128, 64, 128, 2 unit, 2, 4, 8, 16, 32, 64, 128, 256. So the next guy going up is going to be 512. All right. So when we get to 512, we don't want to be at 512. Doesn't matter. It doesn't matter. Well, it might matter because we could go into negative numbers if we go too long, right? All right, so if we get to, instead of doing this, when the counter gets done, we reset the counter, we're going to go and do a compare equal, and when n7 colon 0 makes it to 512, then we're going to reset it. Okay, so we're going to delete that instruction. We're going to clear it. That's what we're going to do. There's the clear instruction. So we'll clear n7 colon 0. We're also going to clear n7 colon 0 if I push the stop button. So I'm going to come down, and if I'm stop, do we remember what guy was stop? B3 colon 0 slash 0 I think was stop. So if I push the stop button, I'm going to clear that integer, and then my speed goes to 0 at that point. I'm going to check my work, and I have some errors. So what is my error? And run 3, instruction 6, parsed entry symbol 1 Charlie 0 H is invalid. Okay, so if I look at that guy, that 1 Charlie 0 H, I see it's not a 0. I put in 1 Charlie O H, and maybe I did that on purpose, maybe I didn't, but see, there's a difference between an O and a 0, and the computer won't be confused about it. All right, so there's our program, and see if we can get it all on one piece of paper and still see it. No, we can't. That's way too small. Anyway, so we'll bring it back big again. So we're doing the sync outputs. We're taking advantage of them to control the DC syncing of the PowerFlex, and we're going and in this particular case we had a channel burned out, so we had to use an add instruction and put the speed someplace else. Alright, so with that ends my discussion on project 5.